Problem number 9 offers our first opportunity to rotate around a vertical line, which you see whenever you see x is equal to something. In this case, we've got x is equal to -1. So our rotation actually involves rotating in a vertical direction. We've got this green area that is formed by the intersection of y is equal to x squared and x is equal to y squared, the intersection of these two parabolas. The interesting thing to note that when we're rotating around a vertical line, all things, including the limits, the dy, and the functions, need to be in terms of y. So I've gone ahead and I've solved this, noting that y is equal to the square root of x. By the way, if you're worried about plugging this into your calculator, this is how it would look. The outer function is the one that's farthest away from the line. In this case, that is y is equal to x squared. The inner function is the function that's closest to the line. In this case, that's the x is equal to y squared part. Notice that when I solved and tried to plug into the calculator, the only thing that I needed to worry about was y is equal to square root of x, because when y is greater than or equal to 0, that's the piece that we get that will actually intersect with y is equal to x squared. So we're rotating around this way. How does the integral look? The key thing in the integral is that we're going to need to solve for x in each of these situations so that we get x is equal to the positive square root of y, which would be the positive part of this first parabola, and we can keep the x is equal to y squared. Remember that that y is equal to x squared is our outer function. So that when we set up our integral, we get the integral from 0 to 1 of square root of y plus 1 squared. The plus 1 comes about from rotating around the line x is equal to -1. And we get y squared plus 1 squared dy when we're rotating the inner radius around the line x is equal to -1. Don't forget your pi's. Notice that the limits are in terms of y. We're going from y is equal to 0 to y is equal to 1. We're stacking up all of our disks in a vertical direction. That would be why we're actually going from y is equal to 0 to y is equal to 1. Again, we've got outer radius minus line, inner radius minus line. Plug that into your calculator. As I mentioned in class, you can plug in terms of y as long as y is the variable you indicate on math number 9. When you do so, you get 3.037.